Hello, everybody. I would like to welcome you to this talk and thank you for choosing this talk among very interesting talks that are currently occurring here. What we're going to talk today, what we're going to talk about here today is continuous security testing. And I can imagine this might not be a very popular theme for this conference that is sort of a broad scoped conference, but still it's a very interesting subject that is relatively new, and security testing tends to get forgotten in this continuous integration process that we kind of strive towards in our development process. We're going to have a talk that's kind of a structured manner today. That we're going to start with the problem that caused us to think towards this security test automation and basically integrating it into our continuous integration process. Then how to solve those problems and what questions do we have when we saw these problems, and then into the very implementation of those problem solved stuff that we built. So first of all, I would like to do I have a clicker or something that I could? Okay. We'll just use this. Sorry for. Well, I can continue basically. For starters, I want to introduce myself. My name is Nenad Pavicevic, and I have been working as a developer, QA, and as a security. Sorry. Okay, and as a security specialist as of late, and I've been working for Novomatic Lottery Solutions. It's a company that's dealing in lottery solutions and gaming solutions, online gaming solutions. And within that company, we have an AppSec team, which I'm assuming that most of serious companies should have and already have. And as you all know, a problem with AppSec teams is they are very small, usually a couple of people in a very large company that usually the entire company has no idea what they're doing. And basically, what I'm trying to explain is what kind of a struggle are we having when we deal with our everyday job. So the challenges that the AppSec team faces here are the fact that we kind of have very short time span for testing we do, and the time span we usually have is put in the last part of the project development life cycle, which is also a problem for us because you don't have very flexible time to report those issues. You want to report them very early in the process, just as any other test and any other bug. You want to have that bug found in a very early process, in a very early part of the process, so you can have a very low cost of fixing it. Also, there's a large amount of tests and scans that we do on very many different projects and products that we have, which also tends to get a lot of repetition in the process itself. So what we kind of have here is a problem that we want to avoid, and we want to make this process automated. And well, I have this image here that kind of puts this thing I'm talking about in a perspective. And this is kind of a software development process that we have. And well, this kind of an iceberg that you see here is a huge project that we usually have in our company. And well, there's almost 10 man years of development that we use to build a project, and then there's just 2 or 3 weeks at most that our team gets to kind of do the testing. And there's a lot of testing to be done, and to make sure that you can say that this application is secure. So if you want to put your signature on something and call it a secure application, you only get 2 weeks for a very huge project. So in order to achieve sort of this possibility to say that this is secure, you want to find those bugs really early in the process and have these 2 weeks really meaningful at the end to do some really cool stuff like hacking and doing exploratory testing, not just running those scans and running all sorts of tests that you need to run every time you do a security audit. Now, before I start talking about security automation, security test automation, and integration into that continuous integration process, I would like to kind of ask you how many of you are familiar with the OWASP project here. Okay, that's a lot of hands up, but okay. Still, I'm gonna go kind of through this so you can have a sense of what this is. OWASP is an open web application security project. It's basically a community of people that are security specialists, developers, QAs that are security-wise very good. And they have sort of opened this project that offers a lot of resources for people that want to do security tests and maybe prevent their applications from having security threats to have it. So, okay, I lost the, okay. First thing they offer is a security cheat sheet and guideline for all sorts of vulnerabilities there are on the web today. And well, security cheat sheet is basically meant for QAs, and it's guideline for them actually to test for and find various vulnerabilities. Guidelines in this sense that I wrote here is a guideline for a developer so they know how to sort of structure and code their code so that it doesn't have vulnerabilities and prevent such vulnerabilities. They also offer a top 10 list of known vulnerabilities on the web, which is a sort of a good starting point for a man or for a person who wants to get into security, sort of to know what out there is the most dangerous thing, or if you have a very short time, which we usually have to test, maybe you want to scratch those top stuff off the list before you go into some further security testing. The next thing on the list is ZAP. That is basically a proxy, Z-attack proxy in this case. This is an abbreviation. It's a simple proxy that intercepts your requests from a browser, and you can alter them in any way you like and just send them to the server. It's also a possibility to intercept the response back from the server and show them any way you want in your own browser. Also, it offers a lot of other functionalities such as scanning your application, spidering your application, and many others that are very cool stuff it offers. And the last thing here, I mean, this is not the full list. This is just something that I would like to kind of say about OWASP that matters in this talk that I'm going to have. But the last thing is the application security verification standard. When I said earlier that you need to say that your application is secure, you want to have some sort of a standard you want to hang on to. You want to say, okay, my application is secure as according to this standard, and this is a standard that provides such a leveling of security. And it offers 3 levels of security. Well, basically what they are recommending is that every application on web should be at least level 1 secure. Level 2 is basically for some banks and financial institutions, and level 3 is really secure applications such as a military grade software or Pentagon stuff, I guess. So that is a really highly secure application, and most of web applications don't need such high security. Okay, let's get back to our talk. So security test automation. After we encounter all these problems in our daily work, we kind of thought, okay, why not automate a lot of processes that we seem to repeat in every security audit we do for all our internal projects and products. And of course, a couple of questions arose. Why should we automate? Does it pay to automate? And what to automate? So why automate is a very simple question. I mean, really very simple answer. I mean, it's security tests as such shouldn't be divided into some separate group. They are not separate or special in any way. I mean, you require a certain set of skills to do them, and well, a certain tool or tools that might not be used in regular testing, but still it's testing, and it should be treated as such. So automation is really good as it is good in any other type of tests. So the next question is a little bit trickier. It was a question that we asked ourselves: what should we automate, and what is possible to automate in this process that we are working on? So the first thing we always do in a security audit is a static code analysis. That's a fairly simple process to automate for us, at least it was in our minds. And it's just running some security static code analysis tool with some plugins, and you just tell them what they should do, and it's basically just reading the report after it. The second thing that we wanted to automate was non-functional tests. They're also fairly easy to automate, as you use mostly the vulnerability scanners in ZAP that I mentioned earlier, or Burp Suite, or whatever you want to use to test for non-functional vulnerabilities in your code. So we thought, okay, that should be maybe the second thing that we should focus on. And the last thing that we wanted to automate was functional tests. Well, security is such a type of testing that it's not that easy to automate functional tests, but we wanted to, and then in this case we wanted to use ASVS, the thing I mentioned before, or the application security verification standard, sort of as a guideline to try to automate all the points that security standard is mentioning there. Okay, so after what we kind of thought, what we should automate and how should we do it, we thought about where does it fit in our continuous integration pipeline. Well, again, these are not special tests. I mean, they should be treated as any others, and we thought we should just put them where the other tests are, and or use the tests we already have to support our security tests. We will get into that later. So basically what we have here is a very simple picture, and this is where security testing fits, just where any other tests fit. Nothing special about it. So when you think about security testing, you need to think about testing, nothing else. Okay, so let's dive into the stuff we did. We started working on static code analysis as a first point that we thought that was maybe easiest thing to get rid of in our process of doing security audits. So we split our code into two code bases that we have, Java code base and Node.js code base, and we wanted to run on each one a dependency checker and a static code analysis tool. So the selection of tools that you see here for Java code base, findbugs and dependency checker from OWASP, as for Node.js, ESLint, and Node Security were selected basically because at the time they were free software, and that suited us because we wanted to do this as a tryout. At the end, it turned out that it's a really good tool, and we kept to it, and it's working just as fine as any other commercial tool, at least for us. So what we did for Java code base, we selected findbugs for static code analysis. Why findbugs was really interesting to us is because it has plugins that you can add to it beside style checker that it has, like a default style checker that it does for Java code. You can add plugins to make your code more secure in that manner. Just make plugins that do security checks beside style checks on your code. So we did that. We made some plugins in findbugs, and we let it run. As for the OWASP dependency checker, it's a really good tool. It just checks your dependency against a known vulnerability database, and it just pops up with a report that says, okay, this dependency you're using here has these known vulnerabilities. For this version, you need to update to this version or something similar. For Node.js, the process is very, very similar. ESLint is an awesome tool for Node.js programming. Another cool thing it has a plugin for ideas, so you can basically do static code analysis while you code, and you just turn on a plugin, ESLint plugin in IDEA, and what you do is add a config file to it with security configurations, and it will just pop up if this line of code is considered unsecure for Node.js code. Node Security is very similar to OWASP dependency checker, just not for Java code base, it's just for Node.js code base. So when we selected these tools and made all these plugins we needed, config files it took to make them work for us, we thought, okay, how should we run them? And we just basically made very simple scripts that are triggered after a build process on our build server, and it just triggers these tools on our binary files, and it sends reports to the security team. It doesn't send it to us. We'll get to that later. Just to show you how, I'll show you how the process goes at the end. It sends it to this issue tracker, but we'll get to that. Okay, next thing were automated vulnerability scans. Most of you guys, I guess, if you have done a security audit in your work, you've used one of these tools, OWASP, ZAP, or Burp Suite, as a proxy for basically intercepting requests and just fiddling with them, fuzzing them, and whatever you wanted to do, and running active scans or spidering your application. So what they need to do an active scan on your application, they need a list of endpoints. You basically need to crawl your website in order for this tool to receive every information you have about your resources, pages, and everything, so we can run active scans on them. So we thought, why not use what we already have? And we do have a lot of automated regression test suites that teams working on our projects have already built. Why not use that as a crawler instead of using crawl within the scanner? This would be the best thing, because crawler not necessarily has to discover every resource you have on your application. These tests, if they are written well, and usually they are, because the team that built the part of the app or the app usually knows what the app does and what the endpoints are, and they have tests for it, and you can use them to discover, run it through the proxy and discover all the endpoints you need. So that's exactly what we did. We changed the way our regression test suites run on our machines. We kind of proxied all tests through these tools, and just after the tests are done, we run active scans on it. And when the active scan is done, we send the report back to the security issue tracker. Okay, the next thing was functional security test automation. This was the tricky part. These tests need to be written. They don't have convenience of just running some tool to help you. These are tests that you have to write yourself, and well, in order to write them, you need to kind of think of them as security acceptance tests. What do you need in your test suite, security test suite, to be sure that your application works securely and is secure? So we wanted to use ASVS level 1 as guideline, as I said before, and we did. Some parts of ASVS are able to be automated, some are not, unfortunately, but most of them are really good as a guideline to what you can do to make those tests, at least if you cannot automate them at all. For example, in ASVS you have these kind of categories that you want to test for, and one of them is authentication, for example. There's some session management stuff, a lot of those categories. And for example, we were focusing initially on those two categories, authentication and session management. We wanted those two to be very secure for us. I mean, those probably are the most secure, the parts of the system that need most security. So we tried and we succeeded in automating at least 60% of that, and it's possible to do that. I mean, tests are written in whatever testing framework you want to use. For example, we used some Postman tests for that, automated them with Newman. We used Selenium tests. We used whatever test framework we could find. We have some custom framework. It doesn't matter, but basically you can use whatever test framework you desire to achieve this ASVS automation you want for your functional security test acceptance test suite. Okay, so we got to the part where we need to keep track of all these tests that we did. So we have these static code analysis tools that produce some sort of a report. We have this non-functional tests that also have some reports that are produced by those proxies and tools such as Burp and Zap and whatever you use. And lastly, we have those acceptance tests that you also can make into a report of some sort. Now, if you have all those reports that are all in different formats, even in different file formats, if not in different formats, so you need to somehow aggregate them and normalize them so you can view them in a single tracking system. For that, we use ThreatFix. It's a really interesting vulnerability aggregation management system. It accepts reports from most of these tools that I've mentioned. For example, it doesn't support ESLint, but what it does support, it supports writing plugins for these reports. So you can write a plugin to enable Threadfix to accept such a report and tell it how to parse the report it gets. Okay, so once you get all those reports uploaded to Threadfix, Threadfix does a really cool thing. I don't know how many of you are familiar with CWE. That's sort of a vulnerability enumeration standard. So you have some sorts of vulnerabilities, and they are all enumerated by some IDs. So you know that, for example, SQL injection is some ID 200 something, and then some cross-site scriptings are 300 something. I don't know. I'm just the IDs are not correct. Don't quote me or something. But what it does, it puts all those reports and kind of enumerates them in that one standard. So when you open up Threadfix, all those reports that are imported, you have like one huge issue list that has all those issues from different reports standing right there. Now, most of companies have some have one issue tracking system, as does the one I'm working in, and we need to kind of coordinate this Threadfix vulnerability management system with the management system that the rest of the company is using. And luckily for us, Threadfix has a plugin for Jira that we were using, Atlassian's issue management system. And it's a really simple integration. Once you get that list of issues, you just click for an issue you want to report in Jira on one button, and it pops up back in Jira as an issue related to the project that you were making the security audit for. And well, we had some problems with reporting such issues from Threadfix to Jira, as Threadfix tends to write some somewhat descriptions that he was writing were not that very obvious for people who are not into security. So we had to write additional description on how to reproduce issues and how to find them, basically, maybe even in the code. If they're in the code, we had to make an explanation why that part of the code is not secure and what it does to the system if it's exploited. Okay. So once we have finished this is basically what we wanted to automate. This is what I've talked about from the beginning, is basically from finding a bug right after the build process to reporting it in your issue tracker is basically automated, except for this part where you need to go into Threadfix and check if that bug is a false positive or maybe has higher or lower priority than it was reported in Threadfix. On this picture, I'm going to kind of demonstrate the entire process that we have. So our build system is Bamboo, and right after developer commits some code that he just made, it gets built, of course, and it heads up to this code analysis part. This is the first part in our that we kind of did and that we wanted to automate. So code analysis runs that script that I was talking about that starts all those tools: security, static code analysis checker, dependency checker, static code analysis tool, and runs them for Java code if Java code was built, and Node.js if Node.js code was built, of course, and it uploads the report to Threadfix or a vulnerability management system that of your choice. So after code analysis is done, we are heading to deploy, of course. Deployment is done on a test system. After the deployment is finished, we start a scan. Basically, not start a scan. This is sort of a maybe bad wording. What we start is we start a test suite, automated test regression suite that was built by a team who is handling this project. So what it does, it runs all those tests that the team has built through a scan server that hosts either burp or zap or both through the proxy. So the proxy has all the endpoints once it finishes, and once the tests are finished, it starts a scanner, an active scan on all those ports. I don't know how many of you know what an active scan is. Actually, I failed to mention that. An active scan is a scan where you take a request that you intercepted and you actively attack it. You tamper with the data that is in the request, and you basically do an attack, a hack on a server. So after all the active scanning is finished, it creates a report and it uploads a report to the vulnerability management tool, again, ThreadFix. This is sort of the process that we envisioned, and this first part of this process that the human is involved here, or a security tester, is this part right here, the ThreadFix vulnerability management system. So this is the first part where you need to do something. This is all automated so far, so the first thing you need to do is just review these reports that are getting to you every day or every week, or it depends on how often do you set up this process to occur. So in the beginning, I imagined that this will be a huge overload for this guy up here to do, because there's going to be a lot of issues getting reported from all sorts of tools. But as the time goes by, I really believe that this process will get less and less overhead for the security guy that's reviewing these reports, and his job is just going to be maybe before a security audit, you'll just review the last reports from this kind of a process and then just go into your security audit. What this guy does in ThreadFix, he goes through all the issues that he found, that the tools found, and basically just kind of covers: is this tool, is this issue real? Is it a false positive? If it's a false positive, you just don't report it. If it's real, you report it. And if it's real, is its priority real? I mean, for example, if you have a cross-site scripting, for example, vulnerability, but it's in an admin page that nobody uses and nobody cares about, and this tool will most probably report it as a very high and critical issue, but for you it might not be, because that admin is only accessing that page through a very secure network, internal network, that he has no way of compromising. So it might not be that critical. So you want to lower or higher the priorities of those issues before you report them to your issue tracking system, such as Jira or whatever. And that should be the end of this process. So basically, you will have your reports and bugs much earlier in the process than you had in that kind of iceberg that I shown a few slides earlier, where you had this huge problem of doing all this that this process did for you in those 2 weeks. So you have to run these security static code analysis tools, you have to check for dependencies, what they're using, you have to go through all of this in 2 weeks, and then after all of this is done, you kind of go to the exploratory testing and hacking the application for real. So you lose a lot of time just kind of setting up and doing all this, and it could be easily automated. So the next question we're going to ask is how to start this. Well, we kind of started this very small, and I do recommend this, taking baby steps in this process. This is a huge process to take on, especially if you're a small team, and usually security teams tend to be really small. So don't bite off much more than you can eat. Just kind of take baby steps, take smaller projects for starters, take parts of projects that you know that you can easily get on with, and do one security type at a time. For example, just start with static code analysis, start with non-functional testing, I wouldn't recommend starting with functional testing because it takes a while to write the tests, then automate them, then kind of get into that. But for starters, I do believe that it was the easiest for us to automate static code analysis, and that is relatively easy process to kind of follow, build triggers, static code analysis tools, you get the reports, very simple. So don't get overzealous and try to automate everything. It will just kill your enthusiasm, and you will just drop this and get back to your old habits of just doing everything in those 2 weeks or 3 weeks you have. So if you follow these steps, I really believe this is a good start, and you can do this. So well, yeah, this shouldn't be a problem for any team that really wants good security and finding these bugs really early in the process. Well, that would be it. And if somebody has questions. Yep. Yep.
Are you creating the test, or they are created by combination of endpoints and framework creates them by some injection special JavaScript?
The tool itself. I don't know if everybody heard the question. The question was, what does active scanning? Who creates active scanning? Do we create it? Does the tool create it? Framework or whatever? The tools create it. Active scanning is a part of. It's a feature that all these tools have. Zap has it. Burp has it. It's just a feature. Active scanning requires a list of endpoints to do active scanning on. Once you, the way it works basically is when you run a request through a proxy, it remembers the request, it remembers the session you are doing it in, or whatever it needs, and it does a passive scan on it. It just checks what's in the request. It checks if the request is valid in sense of non-functional stuff. For example, do your session cookies have secure attribute on them, HTTP only attribute on them, and some stuff like that. That's passive scanning. And then once the request and response get back and forth, the tool applies active scanning on them. For example, he checks what kind of a request is that. Is it a post? Is it a GET? If it's a post, he tries to fuzz with every post part of it. For example, if it sends a JSON in it, it takes every parameter of JSON. Even if it's not a post, it can fiddle with the headers and URL parameters or whatever. So it sends all sorts of malicious code in there, like SQL injections or cross-site scripting in all those parameters, trying to, kill your code.
And you will get a lot of exception on the server side, but sometimes it will get some response which will be vulnerable to cross-site scripting or something.
Yes. Yes, well, there's a lot of false positives in the sense of those responses getting back. For example, you can get a response that will tell you that it's a SQL injection. You send a request that has a malicious SQL injection in it, and it will return a 500 code that will say this database is SQL. I mean, response will say Oracle error, and some stuff about the database, like this field in this table is over over this limit. For example, you try to send a 15 character string into a 10 character string column. It will just say that, okay, this column is too small to accept this string, or something like that. And that's kind of an information exposure. It's not necessarily a SQL injection. It's maybe just information exposure. You should remove that at any cost. I mean, it still gives the attacker sense of what kind of a database you're using, what are your tables, what are your size of your tables. Basically, he can get a sense of how are you structuring your database, which is a really bad thing, but still it might not be a SQL injection. I'm not sure if I answered your question though, but yes, you just provide him with a request and a response, and he will just fiddle and fuzz those responses with malicious code.
Similar what we do with the JMeter, for example. You tell
Yeah.
you fill the request, then you play around.
Yes. JMeter basically does the same thing for performance and load stuff. It just kind of tries to overload your requests to see where they break. Yep.
So if I got you right, you can't actually do automatic deployments of your CI server because you always have to check if there are any tickets in the system, if there are any vulnerabilities, right?
Well, yeah. Basically, what we do is we're not sure. We couldn't get automatic deployment because if for example, where's the picture? Yeah. If, for example, we got a report here that there's an SQL injection that would stop deployment, for example. But it's not necessarily a SQL injection. It might be a false positive. In that sense, that would be a really bad thing to stop here. But we still need to see that report. Security is not usually not something that stops functionality. So you can still deploy. I mean, your application will work. It might not be secure, but it will work. So you need to react on that as fast as possible. I mean, of course, it depends on how often you deploy, but this kind of continuous deployment process, if you would not do this in continuous integration, but continuous deployment process, I would probably advise not stopping this for errors. If you would say, okay, stop this if a SQL injection appears, this would stop a lot because there's a lot of false positives. Those tools are not perfect. Yeah. Any more questions? Going once? Okay. Thank you.